Today we are going to understand hemoglobin oxygen dissociation curve in detail. So for that we need a graph. So here we have hemoglobin saturation, alright, and this is partial pressure of oxygen. So hemoglobin saturation, you need to understand there is in our blood there is RBC, alright, and plasma. So in RBC there is hemoglobin unit, and that each hemoglobin unit carries oxygen. Each hemoglobin unit carries 4 hem unit, and each hem unit can carry oxygen. All right, and then after there is plasma. All right, in plasma there is also a little bit of oxygen. All right, so these oxygens are contributing for partial pressure of oxygen. All right, and the amount of this hemoglobin saturation is showing hemoglobin saturation. For example, out of 4 hemoglobin, 3 are saturation, then it shows 75% of hemoglobin saturation. So by understanding this basic concept, let's start with the normal curve. So what happens? For this also we need blood vessel. So understand, if this is for example your lungs, all right, and right there what happens, right here the partial pressure of oxygen is 100 mm of Hg, and saturation is also around, sorry, also around uh, 98%. So as the blood moves to different tissue, for example this tissue, this is your hand for example, all right, so what happens, uh, this partial free oxygens are utilized, all right, it is utilized by the tissues, so these are tissue, so partial pressure decreases. So for example it was 100, now right here it was P80, now by coming at hand it goes to P50. So as the partial pressure keeps on decreasing, the hemoglobin which was on the blood, this also comes out, and it is continuously contributing to increase the partial pressure. All right, so at this point hemoglobin saturation point was 98. By coming here at P near this point, the partial pressure was P80, and the hemoglobin sorry, hemoglobin saturation came down to P, uh, let it be around, sorry, let it be around 75%. Now coming right here, the same cycle continues as tissues consumes free oxygen. The hemoglobin also keeps on um, providing their oxygen. All right. So now the air saturation becomes 50%. All right. So this is the basic thing which is happening. All right. So this will give you around the curve like this, S-shaped sigmoid curve. All right. So what is this showing? Where as the, so this is for example 100, let it be 100. Okay. So platyphase is reached somewhere. So what happened, as the blood is flowing, the hemoglobin concentration and partial pressure of oxygen is decreasing, and finally it becomes zero. But which is not the ideal case. It never zero hemoglobin saturation and never partial pressure is zero. This is just a curve to show you that this would happen. Alright. So this is normally happening. So what happens? Let's talk about P50. Partial pressure 50. This is the ideal case which is taken generally to study what happens. So there is around 85% of saturation at P50 value. So alright. So at this point, there is 85% of saturation of this blood. So hemoglobin is 85% saturated and partial pressure of oxygen is 50. So now what happens, as in some cases, for example acidosis and alkalosis, the hemoglobin normally doesn't try to provide oxygen. All right, it it runs normally, means hemoglobin is dropping, partial pressure is also dropping. But now let's get a scenario where there is hemoglobin has oxygen but it is not providing, as partial pressure is not corresponding to it. So what happens, the there is one unit BPG, 23 BPG, which is in our course, in MBBS course, which we need to study. All right, so what it does, we have already seen that there is oxygen on hemoglobin. All right, so it creates tension over there by binding to it. And what happens, it is saying this blood, sorry, it's hemoglobin, to release oxygen. All right, so as this releases oxygen, what happens, this curve will shift. All right, so what happens, now oxygen saturation is, sorry, hemoglobin saturation is 75, sorry, let it be 82%. All right, and partial pressure is still 50. So what this does, this shifts curves towards right. All right, so what this makes, this BPG makes this hemoglobin to release, means by decreasing its saturation, uh, which is not its generally, it's generally what happens, these cycles continues as the hemoglobin is both are decreasing in sequential manner. But what this 2,3 BPG does, this create tension in hemoglobin and it makes that oxygen to be released, which makes P50, we are taking this as a value, it makes P50 achieved before hemoglobin correspond to that point. So this is right shift. So what is left shift? Let's see. So this is left shift. So in left shift, what happened? Uh, this BPG is not in left shift. Uh, the RBC is more prone to oxygen, so they are not trying to leave the oxygen easily. Their binding affinity is more. So in plasma, there is no free oxygen, but this hemoglobin, which is a storing unit of oxygen, they are not trying to give it out. All right, so their saturation is 90%, means they have hemoglobin have enough oxygen, but they are not pretending to give it out in the plasma to be used by the tissue. So there is less partial pressure of the oxygen. So this is left shift. So what is happening there? It Hemoglobin has oxygen, but it is not providing the tissue to be consumed. So, but it is not providing plasma to be given to the tissues. All right. So this is left shift and right shift. I hope I could make this graph clear. So if there is no BPG, it is not intense state, means it is not pretending to the give. So low BPG means this hemoglobin is not trying to give out oxygen easily. So BPG is like a pressure, all right, which squeezes out this oxygen out of this hemoglobin in the plasma. So I hope I could make you understand. So generally what is happening, uh, those both things, uh, what is that, a partial pressure of oxygen and hemoglobin saturation is running in a sequential manner, both are decreasing, and I've already showed you that. And what happens in right shift, the oxygen from the hemoglobin are made to be released in the plasma to make the partial pressure of the oxygen more, so that the more oxygen would be available for the tissue to be utilized. In left shift, what happened, the oxygens are more uh, firmly bind to the hemoglobin molecule, so less of the oxygen are available in the plasma. All right. So this is generally happening in lungs. All right. And this is generally happening to the tissues. All right. And this is normal phenomenon which is happening, and this normal curve plots. But this left and right shift also happens if there is some issues like anemia. All right. So in case of anemia, what happens? We have less of the hemoglobin. All right. So our hemoglobin is made to release oxygen by 2,3 BPG. This is not a simple single thing which contributes to be release of oxygen. There are more things like carbon dioxide and more other things you would study, then you will easily get out of it. But the main thing which I want to teach you that how this curves really works, and what normally happens, what happens in the condition of tense and what happens in other condition. So left shift might occur in abnormal situations or normally, based on the situation. For example, where you are, what is the temperature of your body, and other things. So I hope I could make you understand the things. I have given my best from my side. If not, then what your questions are, you can comment down below. Thank you.